Today our topic is linked list. Before learning this video, please consult our previous video of this series on linked list. Then this video will be more clear for you. In our previous video, we already learned how many types of linked list are there. That is singly linked list, circular linked list and doubly linked list. And we already learned different operations on singly linked list in our previous videos. Today we will learn circular linked list. So why we will learn circular linked list? The main disadvantage of linear linked list is that we cannot find the addresses of the node that precedes P. Means what? Say this is one node, this node address is P is 3000. So what is the next node address? It is P arrow next. What is the next node address of this node? It is P arrow next arrow next. But we can't get the addresses of the node that precedes P, means we can't get these addresses 1000, 2000, etc. That is one of the important disadvantage of linear linked list. But if the linked list is circular, means after last node there is no null, it holds the address of the first node. Then we can traverse the whole linked list circularly and we can get the addresses of the node that precedes P. So to remove this difficulty to get the addresses of the node that precedes P, we have to learn a new linked list called circular linked list. In this linked list, next part of the last node contains the address of the first node instead of the value null. So here last node contains the address of the first node instead of null. There is no natural first or last node in the circular linked list. Because it is circular, there is no natural last or first node. So we take the convention that the external pointer holds the address of the last node. So external pointer holds the address of the last node. Say this is our last node, so external pointer holds the address of the last node and next node is the first node. So this node next part holds the address of the first node. Now we will learn different operations on circular linked list. Our first operation is insert a new node at the beginning of any circular linked list. Means how we can insert a new node at the starting, means after the last node I have to insert our first node in the circular linked list. Insert a new node at the beginning of any circular linked list. Here function name is BeginInsert. I am passing the address of external pointer. I declare in this way struct node double star ext. Means ext is an address that holds another address and that is the address of the last node of our circular linked list. And int x. X is the info of our newly created node. First I have to allocate the space using malloc. So malloc allocate at the time of run struct node size memory chunk and it returns the initial address of this memory chunk to queue. So what is how we can declare queue? We can declare queue in this way struct node star queue, means queue can hold address of any node. Now what is queue arrow info? Queue arrow info is this x. Now case 1, if our linked list is empty, means no node is there, then external pointer contains null. If this is the situation, then our node is the first node, our node is the last node, that is single node. So because it is circular, so q arrow next should be q. It holds its own address and star ext equals to because this is only one node, so star ext equals to q. Now case 2, that is not empty, means whole linked list is there. See, this is our linked list. Because it is circular, the last node address is in external pointer. And I want to insert our newly created node at the beginning of this linked list, means here. I want to insert our newly created node here. So what should be the coding? Q arrow next should be what? Q arrow next should be this 1000. From where I can get this 1000? It is next of 4000. So from where I can get this 4000? It is star ext. So I repeat, Q arrow next should be 1000. From where I can get 1000? It is here, means next of 4000. From where I can get this 4000? 4000 is star ext, that is value at ext. So star ext arrow next is 1000. So I get 1000 in this way, it is star ext arrow next. So Q arrow next should be star ext arrow next. And here what you have to give, because I want to insert this node here, so here you have to give this Q. So star ext arrow next equals to Q, because this is our first node now. So see, I want to insert this node here. So first you have to give 1000 here, and then Q arrow next should be what? Q arrow next should be star ext arrow next, this 1000, and then star ext arrow next equals to Q. But if you first write this line, means if you first give star ext arrow next equals to Q, you can't get this 1000. So remember the sequence. First you have to write Q arrow next equals to star ext arrow next. First give 1000 here, then write star ext arrow next equals to Q, then give Q here. In this way, you can add a node at the beginning of any circular linked list. Our next operation is delete the last node from the circular linked list. Delete the last node from the circular linked list. Function name is tailend. Here also I am passing the address of external pointer or header, and the return type is integer because I have to return the deleted node info part. Now I declare two variables struct node star p star q. P can hold address of any node, q also can hold address of any node. P equal to star ext means content of ext is stored in P. Content of ext is the last node address. It's stored in P. Now case 1. If external pointer holds null, means if star ext equals to null, means no node is there, then deletion is impossible, so return -1. Case 2, single node. How we can check there is only one node in your circular linked list? If P equals to P arrow next. What is P? P is star ext, that is 1000. So if P equals to P arrow next means there is only one node in our circular linked list, because it is circular, and if it is only one node, then P equals to P arrow next. Then after deletion of this node, no node is there in our linked list, so external pointer holds null. So after deletion of this node, star ext equals to null, and x equals to p arrow info. So this info is x. So p arrow info is x, and I have to return this x. So after deletion of this node, I have to return this x, and star ext equals to null. Case 3, normal case, means all nodes are there and I have to delete the last node, this node. In case of circular linked list, the last node address is stored in external pointer. See, 5000 is here, and I have to delete this node. So what I have to do, when I delete this node next part should be 1000, because this is our last node now. But how I can get this node? I have to traverse the whole linked list till we get the node, and when I get this node, I have to give 1000 here. So I start one while loop. While p arrow next not equals to star ext, means p arrow next is star ext. Star ext means 5000. Till the node whose next is star ext, I have to traverse the whole linked list. So first time, what is p? P is star ext. P is this 5000. So this is P. Now check, is P arrow next is star ext? Is P arrow next is 5000? No. Then P equals to P arrow next. Next time P is this node. Now is P arrow next is star ext, that is 5000? No. So P equals to P arrow next. Come here. Check, is P arrow next is star ext, that is 5000? No. So P equals to P arrow next. Check, is P arrow next is star ext, that is 5000? No. P equals to P arrow next. Is P arrow next is star ext? Yes. Is P arrow next is star ext. Now what you have to do? So this is our P. I want to delete this node. So what is P arrow next? P arrow next should be 1000 because I want to delete this node. So this should be 1000. From where I can get this 1000? It is P arrow next arrow next. I repeat, P is 4000, P arrow next is 5000, P arrow next means 1000. So P arrow next equals to P arrow next arrow next. In this way, I am getting this 1000 here. X equals to star xt arrow info. Star xt arrow info means star xt is 5000, 5000 arrow info means x. So I have to return this x. Okay, free star xt. Star xt means what? 5000. So free this node. Star xt equals to p. Now here external pointer points to this node now. This is our new last node. Okay, so star xt equals to p. This p should be here and I have to return this x. So see, first delete this node, return this x, and star xt equals to what? P, this 4000, and here I have to give 1000, that is P arrow next equals to P arrow next, that is 1000. Our next operation is display of a circular linked list. See the discussion first. Display of a circular linked list. Function name is display. I am passing the address of external pointer or header, that is this 600. I declare one variable struct node star p. P can hold address of any node. Here I give p equal to star ext, that is value at ext. It is 5000. So p is 5000. P holds the address of last node. Because it is circular linked list, external pointer holds the address of the last node. So p equals to 5000 here. Now, if p equals to null, means if star ext equals to null, means here if it is null, then no linked list is there. So, it is impossible to print. Otherwise, normal case. I have to traverse the whole linked list and I have to print each node info. So I start from this node, that is the last node, that is from P, and I have to traverse the whole linked list till we get this node. So how we can identify this node? This node is the node before this node, before last node. So how we can identify this node? I can identify this node in this way. This node next is star ext. See, 4000 next is 5000, that is star ext. So I have to identify the node before the last node. So the conditions should be, see, I start one while loop while p arrow next not equal to star ext. So first time what is p? P is this node. Is p arrow next is star ext? Is p arrow next is 5000? No. Then what you have to do? Printf p arrow next arrow info. So first time it will print what? It will print 25. So I print first node info. Next p equals to p arrow next. Now our new p is this one. Now again check. While p arrow next not equal to star ext. Is p arrow next is star ext? No, it is not 5000. Then p arrow printf p arrow next arrow info. So printf p arrow next arrow info means 17, and then p equal to p arrow next. So this is our new p. Again check. While p arrow next not equal to star ext. Is p arrow next is 5000? No, it is 3000. Then printf p arrow next arrow info. So print p arrow next means 3000, arrow info means 31. So print 31. P equals to p arrow next. So p is now this node. Again check. While p arrow next not equal to star ext. Is p arrow next is star ext? No, it is 4000, not 5000. Then printf p arrow next arrow info. So print 13. P equals to p arrow next. Again check. While p arrow next not equal to star ext. P is this node, p arrow next is 5000, it is star ext. So this condition false. So after this while loop, there is another printf statement to print the last node info. So just print p arrow next arrow info. P is 4000, p arrow next means 5000, 5000 arrow info means 2. So just print the last node info. In this way, you can display a circular linked list. Now we will learn how to write program to implement following operations of circular linked list. First, insert a new node at the beginning of any circular linked list. Delete the last node from the circular linked list and display the linked list. See the program. So this is our program. This is node structure. These are required prototypes. This is main. In main, I initialize external pointer as null because initially no nodes are there in the linked list. So external pointer holds null. I start one do while loop. This is one index. First option is begin insert, second is end delete, third is display, fourth is exit, and 5 default. Take the choice from the user. Here I use switch case control statement. Switch choice case 1. First I have to take how many number of nodes user want to insert. Say it is n. Then start one for loop for I equals to 0, I less than n, I plus plus. Take the info part of our newly created node. Say it is y. Then call the function begin insert by passing the address of external pointer and y. In this way, repeatedly call begin insert function for creation of our linked list. Case 2 is del end function. I want to delete the last node from the linked list. Call the function del end by passing the address of external pointer. This function return the deleted node info part and then I print that info. Case 3 is display. Call the function display by passing the address of external pointer. Case 4 is exit and then default. Now this is our begin insert function we already discussed in this video. This is display function we already discussed in this video, and this is del end function we already discussed in this video. So I am showing the total program now. See, node structure and prototype declarations, main, begin insert function, display function, del end function. So when I run the program, see, supply your choice. First begin insert. Supply the number of node user want to insert, say it is 5. Supply the info part of the first node, 11. Info part of the second node, 22, then 33, then 44, then 55. I want to see our whole linked list, option number 3, display. So this is our linked list. See, because it is begin insert, before 11 it is 22, before 22 it is 33. Now I want to delete from the end, that is option number 2. So 2, the deleted node is 11. Now again I want to see our whole linked list. So this is our linked list now. And finally, case 4, exit. So this is your programming assignment. Write a C program to implement following operations of circular linked list. Number 1, insert a new node at the beginning of any circular linked list. Delete the last node from the circular linked list and display the circular linked list. Pause this video, try to do it by your own. These are your homework. Choose the correct option and answer me in the comment section what is the correct option. I am waiting for your reply. For getting more and more updates, please like, share and subscribe my channel. That's all for today. Thank you.